All right, let's do this. We're about to go on a whirlwind tour of, well, the entire universe, all through the incredible insights of physicist Dr. Michio Kaku. We're going to explore the story of physics, from Newton's apple all the way to the Big Bang, and see how just a few simple equations completely reshaped our world. Let's dive in. So let's start with our really simple question. What has physics actually done for you lately? It's a fair question, right? Physics can feel, super abstract, like something that just happens on a chalkboard in a university somewhere. But the truth is, our entire modern world runs on physics. I mean, just think about it for a second. Physicists, they invented the laser, they created the transistor, the tiny little heart beating inside all of our computers. They helped build the internet, and then they wrote the World Wide Web to go on top of it. Television, radio, MRI scans, X-rays. Seriously, pretty much everything in your house, in your pocket, in a modern hospital, you can trace it all back to a physicist. For Dr. Kaku, this whole journey started when he was just 8 years old. Albert Einstein had just passed away, and all the newspapers had this picture of his desk with this caption. He was totally captivated. What could possibly be so difficult that even Einstein couldn't figure it out? Turns out, it was the theory of everything, a single equation to unite all the forces of nature. And that one childhood mystery, well, it set him on his path for life. Okay, so why does any of this really matter? Well, because understanding these big, fundamental forces isn't just about the past. It's the key to understanding our future. Dr. Kaku also had another huge inspiration growing up, the TV show Flash Gordon. And he had this amazing realization. Flash was the hero, sure, but it was the scientist in the background who made everything possible. The ray guns, the starships, the invisibility shields, that was all physics. And it just drives home this one key idea. If you really want to understand where we're all headed, you gotta understand physics. So let's start with the first great force to be tamed, gravity. Before Isaac Newton, the universe was a pretty scary and superstitious place. Comets were seen as like bad omens from the gods, but one man was about to change absolutely everything. For almost 2,000 years, this was what everyone believed. This was the wisdom of Aristotle. And it kind of makes sense, right? It feels intuitive. You push something, it rolls for a little bit, and then it stops. Obviously, it just got tired. But here's the thing. That intuition was completely wrong. And then came the revolution. Newton's first law just completely flipped the script. I mean, think about a hockey puck on ice. It just keeps on going. The only reason things stop here on Earth is because of an outside force we call friction. This was a totally radical new way of seeing the world. And yeah, the legend is actually true. He was just 23 years old when he saw an apple fall. But he looked up at the moon and asked this absolutely brilliant question, does the moon also fall? And he realized the answer was yes. The moon is constantly falling toward us, but its sideways motion keeps it in orbit. And get this, when the math of his day wasn't good enough to prove it, he just invented a new kind of math, calculus, as you do. But here's a crazy thought. All of this world-changing knowledge was almost lost. Newton couldn't afford to publish his work. Thankfully, his wealthy friend Edmund Halley, and yes, that is the Halley of Halley's Comet, paid for the publication of Principia, one of the most important books ever written. And the impact was just staggering. Newton's laws gave us the power to predict the motion of the planets. His second law, force equals mass times acceleration, became the engine of the entire Industrial Revolution. It's why we can build skyscrapers that don't fall down and send space probes past the rings of Saturn. All right, next up, the second great force, electricity and magnetism. For centuries, people looked at lightning and just saw the power of angry gods. But then, in the 1800s, scientists like Michael Faraday started to figure out how to tame it. And Faraday's discovery was just stunningly simple. Move a wire near a magnet and poof, you create an electrical current. That's it. That one single principle is the reason we have power plants, generators, and electric light today. It all comes back to that. And the story gets even cooler, even more beautiful. Physicist James Clerk Maxwell realized there was a perfect symmetry here. He thought, okay, if a moving magnet creates an electric field, then a moving electric field must create a magnetic field. They generate each other back and forth in this continuous cosmic dance. So if these two fields can create each other back and forth, what happens? They ripple outwards, creating this self-sustaining wave. But what is this wave? Maxwell did the math. He calculated the speed of this electromagnetic wave and found it was the exact speed of light. In one of the greatest breakthroughs in history, he realized this wave is light. He had uncovered the true nature of light itself. So, mastering gravity gave us the industrial age, and electromagnetism gave us the electric age. Next came the nuclear forces, the strong force that binds atoms together and the weak force that governs radioactive decay. And together, they unlocked the secrets of the stars. For centuries, no one knew how the sun could burn for billions of years. The answer came from Einstein. His legendary equation revealed that matter could be converted into pure energy. The sun is a giant nuclear furnace, turning a tiny amount of mass into the enormous energy that lights up our solar system. Now, exploring these forces requires some serious hardware, and Dr. Kaku started early. As a high school kid, he went to his mom with this rather unusual request. And incredibly, she said yes. Can you imagine? He built an atom smasher in his parents' garage, blowing every fuse in the house. His poor mom probably wished he just played baseball. But that project won him a scholarship to Harvard and launched his career. So we've mapped out 4 fundamental forces, but the quest is far from over. In fact, what we've discovered has only revealed how much we still don't know. The leading candidate for Einstein's theory of everything is string theory. The idea is incredibly elegant. Every particle is just a tiny vibrating string. Each unique vibration or note creates a different particle. Electrons, photons, everything. In this view, all of reality is a cosmic symphony. And this brings us to the most humbling discovery of all. Just look at this chart. Everything we've been talking about, stars, planets, you, me, is made of what physicists call higher elements, which make up just 0.03% of the universe. All the atoms we know combine to be less than 5%. The rest is a complete mystery known as dark matter and dark energy. So the crucial takeaway is this. Every physics textbook is wrong. They say the universe is made of atoms, but we now know that's not true. Most of the universe is dark, mysterious, and waiting to be discovered. That leaves us with the ultimate question for the next generation. What comes next?